Okay, Addison, you ready? Okay, change everything into sine and cosine. Yeah, this is 29. So these first two are already written in terms of sine and cosine, so you can't change them. Tangent is sine over cosine, secant is 1 over cosine, cosecant is 1 over sine. Are you ready? Sine on top, cancel with the sine on the bottom. Cosine on top, cancel with the cosine on the bottom. So that leaves you with sine over cosine, which is tangent. Done. Waiting. All right, number 30. There's a few different ways you can do this one. For my money, I think the easiest way is just to FOIL that out. Are you okay, old man? You're shuffling up here. Okay, great. The parentheses to me scream out. FOIL. Get rid of parentheses. So, first times first. Secant squared. Outside times outside. Secant tangent. Inside times inside. Negative secant tangent. And last times last. Negative tangent squared. And that's all over secant. Okay? All right, so secant tangent minus secant tangent, those cancel. And then I'm left with secant squared minus tangent squared over secant, okay? Well, now I got some squareds in there, and so that sort of is a clue that I want to use one of these Pythagorean identities. And the one that I want to use is, since this is a secant and this is a secant, is gosh. I sure would, gosh, like to change this tangent squared into a secant. Well, it's close. It's not tangent squared, it's 1 plus tangent squared. But I can subtract 1 from both sides. And so if I know that 1 plus tangent squared equals secant squared, then I also know that tangent squared equals secant squared minus 1, right? Yeah, that's just basic, right? I'm, an informant for the FBI. They were like, you know, you might want to tape this so that the students don't see it. So I was like, no, it's fine, it's okay. You just go for it. Okay, so that means I'm going to replace this tangent squared with secant squared minus 1. Okay? Note the use of parentheses. All right? Then secant squared y minus secant squared y, those will cancel. Negative 1 is 1. And since secant and cosine are inverses of each other, 1 over secant is equal to cosine. Cozy. Time out. Finish your question. Did it work out that way? Because these two things cancel, and then a negative times a negative made a positive. Yeah. Cole, you want to share some frustration? Right. Crazy, huh? Yeah. To be cosine? Well, you know, secant squared y minus secant squared y, those cancel. And then minus a negative 1 is plus 1. Okay? All right, are you ready, GLORIA? No, because it was secant squared y minus tangent squared, so then I substituted it in there and subtracted. All right, number 31. Probably a few different ways that we can go in this. Anybody want to throw out an idea? Yeah. Yeah. No. There's no relationship between secant and cosecant. Common denominator, okay. Yeah, so the common denominator is going to be the two things multiplied together. Cosecant squared times secant squared. So that means that I had to multiply the cosecant squared by secant squared, so that's going to be tangent x secant squared x on top. And then this one over here is going to be tangent x cosecant squared x on top. This might not work. Into sine and cosine? Yeah. Yeah, this might not work, but we'll go down this path until we fail, okay? All right, so now that I have a common denominator, I can rewrite them as a single fraction. Okay, we got a lot of squareds there, and the squareds are over here on this thing. Is there something that you want to substitute in for something else? Should we make all the... What are you doing, Thomas, besides being a distraction? Will you... Oh, my Lord. Will you please sit down? I'm going to try to change all of the secant squareds into 1 plus tangent. The problem is the tangents aren't squared, so... Into sines and cosines? Okay, change everybody into sine and cosine. Okay, so tangent is sine over cosine. Secant is 1 over cosine, so that's going to be 1 over cosine squared. This tangent is also sine over cosine, and this one is 1 over sine squared. You turn the bottom ones too? Yeah? Shelby says yeah. So that's going to be 1 over sine squared times 1 over cosine squared. No, it's going to work actually. Well, here's what I'm going to do next. Since I'm dividing by a fraction, I'm going to multiply by the reciprocal. Okay? So I'm going to take this top part, sine of x over cosine of x times 1 over cosine of squared x plus sine of x over cosine of x times 1 over sine x. And I'm going to multiply that by sine squared x cosine squared x. Yeah. It seems like there's got to be an easier way to do this, yeah. I don't really know. All right, this sine x and this sine x will cancel. If I multiply this stuff right here by this stuff right here, this cosine squared and that cosine squared are going to cancel, right? Right? Because I got a cosine squared on top, I got a cosine squared on the bottom. So that's going to equal, this is a total nightmare. If you don't understand this, then don't sweat it. That's going to be sine cubed over cosine. Sine squared times sine x is sine cubed. This cosine squared and that cosine squared cancel. Still have a cosine on the bottom. And then plus, this cosine is going to cancel one of these cosines, and I'll still have a sine squared on top. So that's going to be plus sine squared cosine. Okay? All right, I can see the end here. There's probably a faster way to have gotten here, but, you know, what are you going to do? So we get a common denominator again of cosine. So I have to put a cosine on the bottom here, which means I have to put another cosine on the top there. Okay? Because, yeah, to multiply the top by cosine because I multiplied the bottom by cosine. Oh, actually I lied. That's going to be 1 plus cosine. That's not what I wanted at all. Yeah, I wanted 1 minus cosine so that I could change it into sine. So this would end up being sine squared times 1 plus cosine squared over cosine. That's a good answer. We'll call it there. We'll leave it there. Yeah. Good. Oh, okay. Okay. You ready? No, I got it. Sine squared is 1. You guys probably could just stop writing this down. 1 minus cosine squared, yeah. Okay. So if I FOIL that out, I would get 1 minus cosine to the, well, nope, that's not going to get me anywhere either. Over cosine of x. Nope. That was a weird one. Tangent of x is where we're trying to get. I don't know. Okay, is 32 the last one? Okay, skipping it. Fun and games that we were playing with solving trig equations. Whoops, because that's the more important part of this section. Rumor has it that, yeah, thank you, that solving trig equations is something that comes up with some frequency on college placement tests. Yeah. Because, you know, it's one of those things where you start with the easy stuff and then you get more and more difficult, and then this is a place where a lot of students go, okay? So you want to try and test into college math, it'd be good to know how to do this, all right? So we did this example, I think, already. Let's do this one now. What I'm saying is well, you're only a junior, but if you were a senior right now, like Corey, your goal for next year would be to test into probably pre-calculus. You want to test into calculus? Maybe. But what you don't want to do is you don't want to test into second year algebra, because that's not a college level math class. But if you don't show that you can do this, then they'll make you, take algebra 2 again, pay money for it, and not get credit for it. It's kind of garbage, yeah. Right, but they're saying, oh, you're not prepared, so now you have to, right, you can't do that. You don't have to know it, but it's helpful. What I've heard from some other students who have taken the placement tests, and individual colleges, like if you go to the U or if you go to Central, they have their own placement tests you have to take. And yes, Miami, the U, thank you. Okay, first step. Set it equal to 0. Okay, first step, set it equal to 0. Okay, Will knew to set that equal to 0 because it has a squared in it. And when you're solving a quadratic, whether it's just an x or if it's a sine x or whatever, you need to set it equal to 0 because your next step is going to be to factor that, okay? This is a little bit different because we're factoring not just with x's but with sine of x's, but it's the exact same idea. If I want the first two things in the parentheses to multiply together to be 2 sine squared, what has to go in the front of each parentheses? A sine has to go in front of 1, and a 2 sine has to go in the front of the other one. Because sine times 2 sine is 2 sine squared. Okay? Then I need two numbers at the end that are going to multiply together to be 1. What are those? 1 and 1. Right. That's the only question then is which one is the plus and which one is the minus, and that's where this middle term comes into play. I need those when I combine my like terms to be a positive sine of x. So these two would multiply together to be 2 sine of x. These two would multiply together to be plain old sine of x. So if I want it to be positive sine of x, this one has to be the positive and this one has to be the negative. So when I combine my like terms, I end up with plus sine of x. So this is going to be a plus and that's going to be a minus. So I got her all factored. Okay? All right, then the reason why that's handy is because if this times this equals 0, you know that the individual pieces have to be 0. So sine of x plus 1 equals 0, or 2 sine x minus 1 equals 0. Right? How do I solve sine of x plus 1 equals 0? Yes, you minus 1 from both sides. So if I minus 1, then I get sine of x equals negative 1. Okay? Some of the weaker among you will have to refer to your circle chart to figure out what those values are. But the stronger of you will know, I didn't say that you have to look, you particularly, but, oh, okay. You know that the sine is the y-coordinate. So where on the unit circle is the y-coordinate negative 1? Right down there at 0, negative 1, which is 3 pi over 2. The y is negative 1, but the x is 0 because I'm on the y-axis. Because I went 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay? All right, if 2 sine of x minus 1 equals 0, then in this case, sine of x has to equal what? 1/2. Because you add 1 and then divide by 2. Okay? So that is not something that I can necessarily find by looking at this. Again, if you want to look at your circle chart, you can. But if you were in a testing situation where you did not have access to your notes, then you would have to draw the triangle. Okay? So for sine to equal 1/2, the opposite side is 1. The hypotenuse is 2. What's this side right here? Square root of 3. So what angle is that? It's a 30-degree angle, but we're always in pi. So a 30-degree angle is the same as pi over 6. Because 180 divided by 30 is 6. Okay? And 60 is pi over 3. Yeah, very good. And then there's another one over here where this is 1 and this is 2. So if that's a 30-degree angle, how many degrees is that? If that's a 30-degree angle, then this is 150 because 150 plus 30 makes 180. So then if I go 150 over 180 to change that into degrees, then that gives me 5 pi over 6. Okay? Yeah. Actually, technically, there's an infinite number of answers because I could go around again. I could add 2 pi to each one of those as long as I want. What? Do it? Okay. The technical answer here would be, since this middle post is pi over 2, and then I can add 2 pi onto that, so that would be pi over 2 and 5 pi over 2. Ooh, that's a tough one, so it's going up by 4. So that would be 4n plus 1 times pi over 2, plus or minus, if I go 60 that way, that's pi over 3 both ways. So that's all of them. Because there's two different places where in the unit circle where the sign is equal to 1/2. Opposite over hypotenuse here, opposite over hypotenuse here. It doesn't work, Gloria, in quadrant 3 and 4 because then the opposite side would be negative, so that's where it would be negative 1/2. Okay? Okay, let's call it there. All right, so why don't you guys work on some trig equations, everybody's favorite.